Hello chemists! Today we're going to be doing a quick review of ions in anticipation of our ionic compound chapter. Some of this will be review from Biochemistry 1 and some of it will take it to the next step to get us ready to jump into ionic compounds. Our big idea for this lesson is that atoms gain or lose electrons to completely fill or empty their valence shells. We'll come back to this idea a little bit later on in the lesson. First, I'd like to remind you about ions. Ions are atoms with charges. This happens when they gain or lose electrons, and the result is that their numbers of protons and electrons, or numbers of things with positive and negative charges, are unequal. If we had the same number of protons and electrons, we would have a neutral atom, or an atom with no charge. We talk about two kinds of ions. The first are cations, which are positive ions. They're mostly metals, and they form when atoms give up electrons, meaning that they now have more protons than electrons, which results in that positive charge. The other kind of ions are anions, and they are negative. They are usually nonmetals, and they form by taking electrons from other atoms. This means they have more electrons than protons, and therefore a negative charge. As a reminder, here is a look at our periodic table. We have metals in orange and nonmetals in blue, and then that zigzag line, the elements in white, those are metalloids. We're not going to worry about them too much this chapter. The one exception to the cation and anion rule that we will see come up over and over is that hydrogen is a nonmetal, but it will form a positive ion or cation. And you'll be able to answer why that is a little later on in this lesson. Here's a quick reminder about the structure of electrons within an atom. We think about electrons as living or flying around on rings or shells. The inner shells are called core shells, and they are always full. Those shells have capacities that we've talked about before. And then the outermost shell with electrons is the valence shell. It can be partially full or full. In this case, we'll talk about it being emptied. The electrons that live on the valence shell we call valence electrons. To figure out how many valence electrons an atom has, we start at the beginning of the row where that element lives on the periodic table, and we count from the beginning of the row across to where we find that element. So for example, carbon is the fourth from the beginning of its row. It will have 4 valence electrons. This periodic table has the number of valence electrons above the main group elements. Let's look at an example. Let's choose selenium. It's number 34. Selenium is pretty far into its row. If we started at the beginning with potassium and we counted across, we would find that it's the 16th element in its row. So technically it would have 16 valence electrons. What we observe is that selenium reacts as if it only had 6 valence electrons, similar to the elements right above it in the same family, like sulfur and oxygen. So for this chapter, we will take those numbers of valence electrons that are at the tops of the columns and extend them all the way down. So if we look in the next row over, bromine, we will assume that bromine acts as if it has 7 valence electrons and work based off of that. So now we're here to our big idea. Atoms gain or lose electrons in order to fill or empty their valence shells. Atoms would prefer to have a full valence shell or an empty valence shell, not something in between. A partially full valence shell is a reactive atom. So those atoms are going to either give up, find atoms to give their electrons to, or they're going to find atoms to steal electrons from, and they'll react with those atoms by giving or taking electrons so that they are no longer reactive. They have a full or an empty valence shell and they are no longer reactive. Let's look at this in practice with a few examples. I'm going to work my way across the second row, so starting with lithium. Lithium has 1 valence electron. It could choose to find an atom to give that 1 valence electron to, Or it could go around and steal 7 valence electrons from other atoms to fill up to 8. We're always going to go with the smaller number, so lithium is going to choose to give up 1 electron, and that will give it a +1 charge, right, minus a negative thing. Beryllium has 2 valence electrons. It could give up 2 electrons or go around and steal 6 electrons. It's going to choose to give up, and so we'll end up with a +2 charge. I'm going to skip ahead a little here. We come to carbon. Carbon could lose 4 or gain 4. And we see that sometimes it does one thing and sometimes it does the other thing depending on the situation and what it's with. So carbon can have a +4 or a -4 charge. Oxygen has 6 valence electrons. It could give up 6 or it could gain 2. It's easier for it to gain 2, again going with a smaller number, so oxygen will have a -2 charge. When we get all the way over to the noble gases, so like neon, neon has 8 valence electrons. It already has a full valence shell, so it will neither steal nor give up any electrons. And this is the reason why noble gases are non-reactive, is because they already have this full valence shell. That's it for today. If you have any questions, leave them in the comments below.